And welcome, Flip Clock fans. By request, we're looking at a Panasonic RC-7580. This was known as the Deerfield. It was also touted as the world's first battery-operated AM/FM digital clock radio. Before we get into it, I wanted to talk a little bit about its history. In some places online they say it was out in '73, but the advertisements show that the clock made an appearance in 1972 actually. And it was pricey. It was priced at $79.95. And the Deerfield in 1973 was still priced up around $80. $80 in 1973 is about $483 in today's dollars. This was not a cheap clock. And here we have one in Flip Clock Fan Studios. It's a nice looking clock, and this one comes with a dust bunny. Talk a little bit about its operation. Here it is, the RC-7580. Takes one battery for the clock and 4 for the radio. Now see that lever right there? You have to throw that lever to get the clock started. And right there in the middle is the time set. I'll show you how to operate this clock. And right there, we'll see where it says clock indicator. That's a typo, it should say whirligig. But anyway, we'll use it for what it is. That is vital, it's crucial on this clock. Here's our battery door. And this compartment happens to be clean. Now, there's 4 batteries on the right, that's for the radio operation, and the one there on the left, that runs the clock. We'll show you that on the inside here in a little bit, and it's pretty important to the operation of the clock. If you've had battery leakage in this compartment, it could definitely be the problem. So even if you think you've cleaned off the battery acid, sometimes it actually acts like a resistor and you'll get continuity. It looks like there should be current flowing, but it'll actually cut down on the current that you're getting. So anyway, we'll look at that. But first I want to talk about how this clock actually runs. So I'm going to show you how lightly you push this lever. And it's not the pushing down that starts the clock, it's the releasing it that starts the clock. That's pretty important. You don't have to get aggressive. Now we see the whirligig there moving down, so it's those little stripes there seem to be moving down. That's the proper motion that you're supposed to see when this clock is operating. That whirligig is going to play a big role in why I think some of these clocks are not running. And it actually happened to me when I was working on this clock, taking it apart to try to get a look at how this thing worked. It actually worked. It actually happened to me. Now, there's a black and a blue wire to the back of that motor. We're going to trace that back. It's a black and blue twisted pair. It's down low there. See that black and blue pair there? We're going to see where it goes. We chase that back and we see the black half, the black wire, touches a common post with this white wire. Now on the circuit board, that has no bearing on the circuit board. It's just a place to connect those 2 wires. If you chase the white wire back, you see it goes into the battery compartment, and it's the positive end of that battery. Now the blue is the negative end. It does not connect to those other blue wires. It's isolated and it comes straight off that, comes through, and it makes up the second wire of that twisted pair. So what you're getting to the clock motor is just straight 1 battery power. If you can get to the clock motor, you should be getting about 1.5 volts from your C battery. This is just kind of a close-up look at the motor itself. It is very hard to get into this, and it could be prone to cause damage. And I think sometimes what happens is people have gotten into the clock and had problems putting it back together. It might be why some of these clocks don't work. Now this is with the plastic cover off. It says it's got 4 joules. You can see a lot of electronics in this motor. It's got capacitors, transistor, and there's our clock indicator, our whirligig. Again, that's going to play a crucial role in why I think some people's clocks are not working. This, just for laughs, is the looking down the top of the motor and seeing it in operation. You can see there's like a flywheel there. There's our clock indicator. You see there's a cut out there of the plastic, so that thing is open. And there's the gearing. There's a white nylon gear in the back, straight back. That's coming off the motor. So again, let's look and see how this operates. It's not the pushing that starts the motor, it's the releasing that starts the motor. You shouldn't have to force this at all, and that's a very light push to get the motor started. That is the correct speed for that little indicator to turn as well. I want to show you how easy it is to get these motors to stop. So if you were handling your clock and you accidentally touch the lever, it automatically stops your clock. So just touching that lever there will stop your clock. So I restarted it here. Now look at the whirligig there, the red and black thing. If I lightly touch, you may not be able to tell, but I'm just very lightly touching. That will stop your clock. That's all it takes. So one of those two things might be happening, and I'm going to try to show you that in detail, why I think that's happening in some cases. Now, you see a lot of wires back here, and it's not a lot of room to work, especially when the clock's been put back together. We can see it, if you look straight down at the top of that motor, you can see the wheels turning. Not a lot of room back in here, and you're going to have to take care when you're disassembling this. There's a lot of small wires that can break off. There we can see, now that piece right there, right in the middle, that back plate there, that's what was causing me some problems. It was pushing up against the motor. I'm going to show you in a little bit why that would cause a problem. So see, here's the plate in place, and you can see there's no room. There's just no room, extra room there. And if that bundle of wires is down a little lower, it'll push right up against the motor or the whole clock mechanism. And what that's did in my case was it was pushing that mechanism forward just about 2 millimeters, and it was causing. Right here is the screws that hold the mechanism in place, but it was causing that mechanism to push forward about 2 millimeters, which was causing this whirligig there to push up against the clock, up against this lens. Now what you don't know is that lens there goes back about 1 centimeter. There was no room for error. It was pushing up against that, lightly touching the whirligig, and it was shutting the motor off, just like that. So normally I tell people, almost as a rule, I tell people if you're tightening up screws, you don't have to tighten them down like you're working on the Apollo mission, but in this case you do. You have to push that back. I'm pushing those screws back, try to get that mechanism back as far as you can, and then tighten that down. Now, got to be careful, you don't want to strip anything out, but I really snugged them down, and once I did that, the clock started working. So there it is, the Panasonic RC-7580, the Deerfield. Hopefully this will help somebody get their clock running, get it back on the road. Thanks for taking the time.